Hi, folks. Welcome back to part 3 of 1.1. So in this part, we're going to be looking at evaluating and interpreting functions, okay? We've got a bunch of examples to work through. Feel free to skip around as you see fit, but I'll try and do my best to explain each of these examples, all right? All right, so let's start with example 8. It says evaluate f of x equals negative 3x squared minus 4x plus 4 at some specific x values. And so let's start here with x equals 2, right? All right, so at x equals 2, we've got f of x equals negative 3 times 2 squared minus 4 times 2 plus 4. All right, so all I've done here is gone ahead and taken this 2. Oops, this should say 2. All right, plugged in a 2 everywhere I see the x. All right, so everywhere I see an x, I'm going to go ahead and plug a 2. And now the only thing we really have to be careful of is that order of operations. All right, so we got to do any exponents and parentheses first before we do multiplication. All right. So let's see what this gets us. We're going to get equals negative 3 times 4, right? Because 2 squared is 4. Minus 4 times 2 is 8 plus 4. All right. Negative 3 times 4 is negative 12 minus 8 plus 4. And let's see, let's get negative 8, taking away 8 from negative 12 gives us negative 20. Plus 4 gives us a negative 16, right? So when we go ahead and evaluate, we get f of 2 equals negative 16. I actually want to write that over here. So f of 2 actually equals negative 16. And so what all that means is this is our x value, our input, and the corresponding output or y value is negative 16. Okay. Remember, we don't actually multiply like f times 2. That's not what that means. That means we take the 2, we put it into the function. All right. Now that's a really important concept because in our second part, x equals a plus h. So what that means is everywhere we see an x, we're actually going to replace the entire thing with a plus h, all right? So we're going to get f of a plus h equals, make sure we copy this down correctly, negative 3 times a plus h squared minus 4 times a plus h plus 4. So everywhere I see the x, I'm replacing it with a plus h. Right? Now, I have a lot of students who like to skip ahead at this point, all right, which for some of us works out well, and for some of us, most of us actually doesn't work out well, right? And so here's what I want us to be really thoughtful about. Remember in that last video, I talked about how we couldn't just take the square root of both sides, right? So if we zoom back up here, I had said, oh, if we have square root of 3 squared minus x squared, I can't just cancel all the squares and get 3 minus x. Well, it turns out we're dealing with something similar here, okay? So number one mistake I see, we see a plus h squared, and someone's like, great, a squared and h squared, right? But what we're forgetting here is that we actually have a plus h times itself. That's what the square means. So what we get is negative 3 times a plus h times a plus h minus 4 times a plus h plus 4, right? So this a plus h squared really breaks down to 2 of them multiplied together. All right. Now, because this is the first time we're walking through this, I want to make sure that we are remembering how to FOIL or distribute, right? So I'm actually going to keep the -3 out here first. And then I've got a times a, which will give me a squared. Then I've got the outer terms, a times h is ah. The inner terms, a times h is ah. So plus ah plus ah plus the last terms, h times h gives me h squared. My recommendation is to FOIL this first, and then you can take that -3 and distribute everywhere. Okay, so do the FOILing first and then distribute. All right, what do we get when we distribute over here, though? This is another place where folks tend to make mistakes. I'm distributing a -4, so this is -4a. But when I distribute it here, it's -4h. All right, so we actually end up with -4a minus 4h. And then don't forget about this plus 4 at the end. Okay. All right, let's go ahead and distribute this -3. We've got -3a squared minus 3ah minus 3ah minus 3h squared minus 4a minus 4h plus 4. Whew, that's a lot. All right, I'm going to cheat a little bit because I can here. I'm going to squeeze this just a touch smaller. And we're going to put one last line under here where we just try and combine any like terms that we have. All right, and we don't always have a lot of like terms, but sometimes we do. And so it's important to scan through and make sure we've got them. All right, so I only see this one a squared. All right, and I only see this one h squared and an a and an h. So we're all going to leave those. But I notice here that I have a -3ah and a -3ah. So I can actually combine those, and I'll end up with -3a squared minus 6ah minus 3h squared minus 4a minus 4h plus 4. All right, so this, my friends, is what we get when we substitute in a plus h. Okay. All right. Last question here, and I'm going to cut and paste this function just so we can see it down below. Whoops. All right. So we have this f of x equals -3x squared minus 4x plus 4. And this question is a little different. F of x equals 4. All right. So here's what we don't mean. Let's write this in red. This does not mean log x equal to 4. That's not what this means. What it does mean, however, is log y equal to 4, right? Because f of x is a fancy way of saying y. So really, we're just taking everywhere we see an f of x, we're going to replace it with 4. Well, if I look at the equation that I copied and pasted, where do I see the f of x? I see it on that left-hand side. So I need to make the whole equation, -3x squared minus 4x plus 4, equal to 4. Okay, that is a really important concept, and I want to make sure that's something that makes sense. All right, so if you have a question on that, please reach out. But we end up with 4 equals -3x squared minus 4x plus 4. And in this case, we actually want to solve for x. We want to get x all by itself. Okay. Now, I notice here that I've got a 4 and a 4. And so what I'm going to do is go ahead and subtract 4 from both sides. and I get 0 equals negative 3x squared minus 4x. Now, we're also going to spend a bit of time working on this summer, okay? One of the things that we are going to spend time working on is factoring, okay? Being able to factor. And one of the things when we get to that, all right, it's really important when we factor that we actually have the equation equal to 0. All right, so if the equation doesn't equal to 0, then all of the steps actually don't really make sense, the ones that follow that. Now, luckily, we have ours equal to 0. And so what we're going to do, we're going to focus on this right-hand side. And the question we're going to ask ourselves is there a greatest common factor on this side? And I noticed that both terms have an x. So I can say 0 equals x, parentheses, I'm factoring out the x, I get negative 3x minus 4, okay? Now, if you had said, oh, Judy, I actually wanted to factor out a negative x, like negative x, and you get 3x plus 4, that would have been fine as well. Okay, so both of these versions are fine, as long as our signs match when we distribute back and we get to the original, okay? But the powerful thing about having our equation equal to 0, in fact, this is so powerful, it's something called the zero product property, is that we can take terms that are multiplied and set them each equal to 0. Okay, so we can say x equals 0 and negative 3x minus 4 equals 0. All right, now this already is solved. X equals 0 is one of our answers. But over here, we have to add some things, divide some things to get our x value, right? So in particular, I'm going to add 4 to both sides. Negative 3x equals 4. And now I'm going to divide both sides by negative 3. And I get x equals negative 4 over 3. Right? So one answer for x is 0. And another answer for x is negative 4 over 3. Okay. Now, here's what I would suggest that you do, right? So let's zoom back out for a moment. We've got 2 questions where we're just plugging in something for x, right? I think so. Most of us probably feel really good about plugging in the numbers, but maybe feel a little shaky on stuff like part B, all right? Lean into where things are confusing. Spend some time to practice some stuff like B, all right? Don't look at this and be like, oh, I'm just going to study A and I won't worry about B. Okay, that's a surefire way to not find success in this class, all right? But you'll have a chance to do some practice problems like this on the MyOpen Math assignment, probably also on that week 1 quiz, all right? We're also going to be working on stuff like this, right? So making sure we know, am I plugging in something for X or am I plugging something in for Y? Okay, so making sure to focus your attention on these last 2 pieces, I think would be a lot more bang for your buck than only knowing how to do part A. Okay. All right, so that's our first example. If you want to try working through some of the other examples on your own, this is a good time to pause the video and then come back when you're ready to check your answer. Okay. Now, for those of us who are going to stick around, let's go ahead and move on to the next example. All right. Number 9, evaluate h of x equals the square root of x minus 4. Yes, we're going to throw in some square roots and just see what happens, okay? All right, so when it says x equals 5, all that means is we plug in 5 for x, right? Everywhere I see an x, I'm going to put a 5. And so what does that look like? Well, h of 5 equals the square root of 5 minus 4, right? Everywhere I see the x, I replace it with the 5. and we do a little bit of mental math. Square root, let's see, 5 minus 4 is 1. So square root of 1. And this is a nice square root, so I would want us to simplify this, okay? All right, let's take a look at example 3 here, or sorry, B. It says x equals 3, x 3. Just like part A, I'm going to plug in 3 for x, right? So the only thing that's different between part A and part B is I'm asking us to plug in a different number, right? So let's go ahead. We've got h of 3 equals the square root of 3 minus 4. So plug in 3 for x. Highlight that as a nice visual for us. Let's see what we get. Negative 3. Oh, sorry, 3 minus 4 is negative 1. All right. And if we put this into our calculators, we're going to get an error. And some of us might start to panic and be like, well, I must have typed in something wrong. So this has got to be negative 1, right? But that is not true, right? This, in fact, becomes I, right? The square root of negative 1 is I. Now, it's okay if you're like, I've never heard of I before, all right? Now we're throwing other kinds of letters in here, but some of us might be familiar with I, this, might even call it an imaginary number, okay? But we'll talk about that more as we get into our class, but I just wanted to kind of start to remind ourselves of some things that might come up during this class that we may have seen before, okay? All right, last but not least, h of x equals 2, well, that means everywhere I see h of x, I have to replace it with 2, okay? So in my equation, I'm going to get 2 equals square root of x minus 4, right? In other words, 2 equals square root of x minus 4, because this means plug in 2 for our y, or our h of x, okay? All right, how do we solve these kinds of equations? Well, I've got the square root all by itself, so I'm going to go ahead and square both sides, all right? So I'm going to get 4 equals x minus 4. I'm going to add 4 to both sides, and I get 8 equals x, all right? So there's example 9. Thinking about plugging in different things in different places, but also a reminder that we will not always just be working with real numbers, okay? All right, let's move on to examples 10 and 11. The directions here are a little bit different. They say express y as a function of x, all right? In regular people terms, what this means, express y as a function of x means isolate y, all right? Solve for y, get y all by itself. All of those mean the same thing, all right? So when someone says express y as a function of x, you need to get your y all by itself, all right? So let's begin with example 10, all right? I've got x equals negative y cubed, or negative 8y cubed. So I'm gonna go ahead and add this to both sides. All right, x equals 8y cubed. All right, now I need to get the y by itself. I actually have to divide this 8 first, and then I can get rid of this cube. All right, I'm going to divide both sides by 8. I get x over 8 equals y cubed. And then to get the y all by itself, I need to take a cube root, all right? So y is going to equal the cube root of x over 8. Now, we want to make sure we know some nice numbers without a calculator. And one of those is the cube root of 8, all right? Turns out the cube root of 8 is 2 because 2 times itself 3 times gives us 8. And so what I would expect for us to have in something like this is the cube root of x divided by 2, okay? No need to go any further than this, but this would be a good stopping point for us. All right, so we have successfully expressed y as a function of x by isolating y in example 10. If you want to pause the video now so you can try 11 on your own, that would be great. But we're going to go ahead and do that one together right now. All right, so a trick that I like about working with things that have fractions is I actually like to get rid of fractions whenever I can. Okay, so if I look at this example, I've got y squared over 4 plus x squared over 9 equals 1. I've got a lot of fractions. So here's what I'm going to do. I'm going to take the entire equation and I'm going to go ahead and multiply by 36. And let's see why I chose 36. So I'm going to get distribute, distribute, distribute. I'm going to 36x squared over 4 plus 36y squared over 9 equals 36. And now let's see what reduces. 36 over 4 goes to 9. And 36 over 9 goes to 4. So really, I have 9x squared plus 4y squared equals 36. And I know this was extra work, but now I've gotten rid of the fractions, which can be really helpful when we use stuff like this, not just in pre-calc, but also in Calc 1 and Calc 2 and Calc 3. It can be really useful for us to know how to get rid of those fractions, okay? All right, but our overall goal was to get y all by itself, right? So, whoops, I'm gonna go ahead and subtract 9x squared from both sides. I get 4y squared equals 36 minus 9x squared. All right, now I have to divide by 4 and then take the square root. So y squared equals 36 divided by 4 is 9 minus 9/4 x squared. All right, we've got one last step here. We have to take the square root of both sides. Y equals, ooh, we just talked about this, square root plus or minus. Square root of 9 minus 9 over 4x squared. Here's what we're not going to do. Okay. Don't do this. Don't do this. All right. This is illegal, very, very illegal. All right. We want to make sure we know this is connected by a minus sign, or even if it was a plus sign, so we can't just take the square root of everything. Okay. So that means that our answer is this for question number 11. Okay. All right, my friends, we've got 2 more examples left here, and we are just about done. All right, so 2 more examples. All right, so example 12 looks like we've got a table. We've got some n values that go across, and we've got some g of n value, okay? So I know our tables have been up and down, like vertical in columns, but they can also go side to side like this, and it's fine, all right? So questions for us. Does this table represent a function? And if so, is the function one-to-one? All right, so we got to remember those questions we asked ourselves earlier. It's a function if every x value only goes to one y value, right? And in my x's or my n's, I only see 5 numbers and they're all different. 1, 2, 3, 4, 5. Okay, so yes, this is a function. And we have to explain our reasoning, right? Explain your reasoning. So because each x value only shows up once. Okay, yes, this is a function because each x value only shows up once. So since it's a function, now we have to answer this question, is it one-to-one? All right, one-to-one, that's that horizontal line test, right? If it crosses more than one time. Or it could be that y values show up more than one time. And I notice the 8s show up twice and the 6s show up twice. So even though this is a function, no, this is not one-to-one. I'm going to abbreviate B/C because some y values show up twice, right? Some y values show up twice. And in particular, that's the 8s that show up twice and the 6s that show up twice. All right, now let's take a look at part B. It says evaluate G of 3. Well, that means that G of 3 means n equals 3. All right, so let's use our table. We're going to go over to where n is 3. That's at here. And the y value that goes with it is 7. So that means that G of 3 equals 7. Okay, that's how we read the table. All right, last question here. Evaluate G of x equals 6. Well, this means, it means that I should have wrote an n in here. First of all, G of n equals 6, all right? But this means find n where y value is 6. All right, so let's go back to our table. Let's look at the y value column. Where do we see 6? Well, I see it here, and I see it here. That means that n could be 2, or it could be 4. Okay, so we can say that n equals 2, 4, and that means in both places, the y value of this function is 6. Okay. All right. Last question here in 1.1. And we've got a lovely graph to finish us off. Okay. So does this graph represent a function? And if so, is the function one-to-one? Explain your reasoning. All right. So the first part, is it a function? That means vertical line test. Yes, it passes the vertical line test, so it is a function. But to see if it's one-to-one, I need to do the horizontal line test. And pretty soon I can see it crosses more than one time. So it actually fails the horizontal line test. All right, so does the graph represent a function? Excuse me. Yes, it is a function. Right, yes, because it passes vertical line test. It is not one-to-one because it fails, it fails the horizontal line path. Okay. So yes, it's a function, but no, it is not one-to-one. Now, how do we find values on the graph, right? This says evaluate f of 1. This means x equals 1, and what is y, right? So on our graph, let's find x equals 1. That happens to be, let's mark this with a nice pink color here, right? F of 1, and this y value is 0, so f of 1 is equal to 0. All right? Last but not least, evaluate f of x equals 4, all right? This means y is 4, and what is x? Right? Now, I like to find the points on my graph. Let's go with orange. And where do I see a y value of 4? So y is 4 up here. That means that this point and this point both have a y value of 4. So when I list my answer, I actually want to give two different x values, right? X equals -1 and x equals 3. Right? So -1 because that first orange point has an x value of -1, and 3 because the second one has an x value of 3. Okay? So, moral of the story here is we want to know how to represent things in multiple ways, all right? Whether it be a graph, a table, a mapping diagram, an equation, and we want to know how to work with all of the different ways, okay? All right, well, thanks for joining me here. Have a wonderful time working on that My Open Math assignment for 1.1, and I'll see you folks back here for 1.2.